Okay, so after all this talk about networks, devices, main devices of networks like routers, switches, and maybe PCs, which are some of the main three devices that you can use in like most of the networks that you work with, that you will work with as an IT or as a network engineer. Just to practice all what you have talked about before, what will you need? You will need maybe like 1, 2, up to 4 PCs, maybe for computers. You will need a switch, you will need a router, you will need a lot of devices to practice on. That is something very important, okay? To practice yourself by using your hands, or maybe using some term you will find in your upcoming courses and in this course, the term hands-on labs, which is practicing real labs, maybe real life gear labs, or maybe using other types of softwares to practice labs and practical sides of really configuring IP addresses, really configuring a computer and a router, and making a real network, maybe having a real configuration to reach the internet, so you can test everything once you have internet inside your network or inside your devices. So this is one important thing. The other thing is that so far what we have talked about are computers, servers, routers, switches, firewalls, intrusion prevention systems. All of these together have the same basic hardware architecture, the same old build basic architecture, which is having like a hardware, maybe a motherboard, a RAM, random access memory, you have a hard drive for storing, you have a flash memory, you will have a processor, of course it will process everything, and so on. All of them are built on a motherboard. This will operate any device in the world, okay? So even routers, switches, once you will use routers and switches in real life in the future, or maybe you have already did, you can disassemble your router or switch will find it's just like a computer. There is a main board, there is RAM, there is flash memory, there is batteries inside, there is power supplies, they will have also some processors, some hard drives, okay, whatever. All of these are the normal devices, just like the computers. After that, what do you have? You have a software or an operating system that is installed upon these hardware, which will give you in the end a result of a device, whether it was a router, switch, firewall. All of them are just like computers. On the other hand, servers also, never be afraid when you hear the term server that it is something that must have like maybe 10 or 50 or 100 specific specification or factor that must be matched and accomplished in order to call some device a server. No, at all. Servers are just normal computers, has the same functions, has the same hardware equipments, no more or less hardware equipments. The difference also is more powerful. Servers are just powerful computers. If you compared whatever you find inside a server, hardware pieces of a server and the hardware pieces of a computer, you will find them the same. You can actually use your computer as a server. You can just install, maybe if you are maybe used to the operating system of Microsoft Windows, you can just install Microsoft Windows Server. That's another thing. Maybe IT engineers, most of them are familiar with Microsoft Windows Server. So this will turn your computer, your normal ordinary computer, into a server. See, the point of all this speech is at the end, all your routers and switches are really looks like computers from the inside, from the hardware perspective. All of them have these main boards and hardware pieces that we have talked about. So all of them are the same. So maybe I can one day have main board from some certain specifications, and I can install on this main board some specific processor, RAM, hard drive, flash memory maybe, and some other details, and in the end I can install a router or a switch software on this hardware, and I will have a router. Maybe I can do so, maybe I cannot. Okay, so this concept of that you will buy some specific hardware, maybe very strong hardware or simple hardware just for testing or for real life purposes, and installing the software of a specific device that you need on this hardware and make it works, it's real, it happened. Okay, so recently in the past few years, few close years, we have this concept has started and it becomes real, becomes a real method that we can all use, which is called the virtualization. I can now virtualize whatever software that I have and install it upon or install it on a hardware, specific hardware that I install or I buy myself. Okay, this will bring me the real services on some devices or most of the network devices on the hardware that I have. So I can now only buy the software from the vendor or from the manufacturer, like maybe Cisco, Juniper, or other manufacturers or vendors worldwide. I can just install them on a hardware that I have bought, I have prepared. Maybe this hardware will be much more powerful and resilient from the hardware that the vendor provide, coming with the router or the switch that I desire, or maybe with the server that I desire. Okay, so now this is possible using virtualization. I can now create by myself virtual machines. I can now create a virtual router or a virtual switch, a virtual firewall, a virtual server. Maybe we will one day hope just to see soon the virtual DNA appliance center, the DNA center that we have talked about of Cisco. It will be very important to have it separated. Okay, so you will find upcoming some of the routers, switches, firewalls, softwares available. All of them have the small v format alongside with the name. Maybe you will have someday the virtual, maybe CSR, cloud services router. This is a router from Cisco. Maybe you'll have XRV, which is some powerful service providers routers from Cisco. These are very giant and very powerful, high resources and high specifications routers provided from Cisco. You will see the small letter V from now on in a lot of the available softwares of Cisco, maybe for routers, switches, and even Cisco's servers. Cisco do manufacture and produce servers also, just like Microsoft, HP, Dell, and a lot of other companies. Okay, so the concept of virtualization, this is a new topic added in this CCNA, in this course of Cisco. It was never mentioned before in the old certification tracks, program tracks of Cisco, and not in any CCNA or CCNP before. Okay, the concept of virtualization will introduce to you now and will show you that you can install a lot. Until now, it's not for every software in the world. Some of them are available in the virtual format, others are not, but most of them are going in this resilience market right now of giving you the virtual software of their device with the same services and every other thing. Okay, you will have only some proper hardware to install and prepare. After that, you can install your software, your virtual software that you got on this hardware. So you will no longer need to wait for the shipment of such hardware to come from you, maybe from the manufacturer and from its factory. Maybe it was in China, USA, in Canada, maybe it's in Europe or in anywhere. Maybe this shipment will take from 1 week to a month to more than a month. Okay, maybe you need to ship like 10 servers, 10 routers. Maybe you will need 50. You will need 50 server or 50 router. You are building a giant data center. Okay, so you will need all these devices available. The shipment of these is very costly. the time you will wait for your project maybe will delay your project and make it on hold. So you can just download the software and prepare a specific hardware with some certain specifications and install the software on all these hardwares. Okay, that's one thing, but that is not the main or maybe the most beneficial purpose or use of the virtualization or the virtual machines. Pay close attention that in case you have prepared a very powerful device, like imagine you will need maybe a processor with 2 cores to establish or install a server software, maybe you will need a hard disk drive or maybe only 10 gigabytes and a random access memory, let's say of about maybe 2 gigabytes. Okay, all of these are the requirements to install a software server upon the hardware that you have prepared. And instead of waiting for Microsoft, Cisco or any other vendor to send you the server, you already have some hardware specifications ready in your lab. You already have them under your hand. Okay, so the other big benefit and very important benefit of virtualization is that in case you need only these specifications to operate single server, but the truth that you have maybe a very strong processor of maybe 8 or 12 cores, okay, with a hard disk drive of 100 gigabyte that you have prepared inside your hardwares, and maybe you have a RAM, a random access memory of, let's say, 32 gigabyte. You already prepared these hardwares and you want to install more than a server. Virtualization allows you to install more than a single virtual server inside or upon these hardware. You can now have one box of hardware and you can install all these specifications, maybe your RAMs, maybe your hardware, your hard drive, your processor, and these are the RAMs. Maybe you can install all of these in a single hardware, or maybe you can call it a single platform, or this is an R, maybe you can call it an appliance. It's also another term used in the market to talk or express a hardware device, a hardware box. Okay, so maybe you have prepared this device, only one device, one single device. You can install maybe 4 servers or whatever amount of servers on this single hardware, on this single box, this appliance alone. You can install 4 servers and prepare a network interface card, an NIC, for each one of them inside this single box, and virtually you will have like 4 servers installed inside one box. That's it. And you can connect between them. You can establish a virtual connection between them. You can make them behave like they are connected together. After that, you can take all of their ports and connect them maybe to a switch in here, and that's it. They are connected to the outside world or to your network or whatever devices you want. So this is the concept, or this is 2 of the main concept of virtualization. Let me take this off. Okay, concept number 1 is that you can install whatever virtual software that you have upon the hardware that you have prepared, whatever virtual or operating system that you want upon whatever hardware that you have prepared. And concept number 2 is having virtual machines, more than a single virtual machine inside one hardware box, inside only one hardware devices. So virtualization do introduce to us virtual, not just networks. We can just produce networks. So I did already produce a network. I did bring only one server and install it like 4 virtual softwares on this server and make this box function as 4 servers, and then I connected all of them through a switch. That's it. It's a network. It's 4 end devices, 4 clients, 4 servers connected to a single switch, and that is called a network. So it's just networks, but in a virtualized environments. Okay, it's not really 4 servers I have installed in the rack. I can do multiple devices inside one, and this will give me very important thing with it, which is ease of management. I can log in a single device and control or operate or edit all the 4 servers that I've mentioned from a single platform, from a single point of view, or from a single GUI interface. This is very important to do so. Okay, so how do all this happen? Do I just bring a server and install the software maybe 4 times? Maybe I can, let's say, I bet that most of you did this move before, did this action where I want to maybe before, back maybe 10 years ago or 13 years ago, when we had maybe like Microsoft Windows Vista, and we did already use maybe like Microsoft Windows XP. So I want to know the difference between them. Will I become familiar and make use of Microsoft Windows Vista before jumping to it and leaving the XP that I have been using it for years before? So maybe most of you did this action where we can maybe take our hard drive, may split it into some partitions, install Microsoft Windows XP on our main partition, which is the C partition, and install maybe Windows Vista on the D partition. Okay, and in each time I boot my computer, I will choose whether to boot from the OS that is installed in the C drive, the C partition, or in the D partition. Sometime I will log to the Microsoft Windows XP, other times I will log into the Vista. I will check this and this separately. But to compare maybe functions and programs between these two OS, I will have to reboot every maybe 10 minutes. I will check maybe Microsoft Office on Windows XP. Now I want to check it on Microsoft Vista, so I must reboot my device and choose the other one. Choose Microsoft Vista to reboot my hardware, to reboot my Microsoft Vista on this hardware, okay, and compare it. I will keep doing this on and on. This is the problem. Or maybe nowadays you will use this action again. Maybe you can install the Linux on partition D and use your Microsoft Windows 10 on partition C, and you will compare them, but you will still have to reboot every 10-15 minutes or whatever time you need, just to use some function that is specific for Microsoft Windows, and next to use a function that is specific to Linux. Okay, so this is really annoying and waste of time. So what we will need is virtualization. I can create virtually the Linux operating system inside my computer and make it up and running all the time while I'm using Microsoft Windows 10 in another window. This will be very easy to use, and we will see this in the upcoming software. So to do so, and the main new term and new function of virtualizations that came with virtualization is called the hypervisor. The hypervisor is a virtual thing that you will not see. It's a virtual operator that you will not see. It's not a device. You will not go to a shop and buy hypervisor as a device. You will buy it as a software. So virtualization, the hypervisor, sorry, is a software. It's more like a software. But what it will do is a new mediator that sits or operates between the software that you want and the hardware that you provide. So before we had like maybe Microsoft Windows operating system, and we have to install this on the specific hardware that I provide, whether it was a processor, a RAM, a hard drive, a graphic card, the GPU, the graphic cards, okay, or whatever hardware specifications that I provide. Now what happens is you have a hypervisor. You will have the software that you want to run, the operating system, and the hardware that you provide, and in the middle a mediator will come that is called a hypervisor. Hypervisor will now take control of the distribution and communication between your software and hardware, and having the hypervisor in the middle will allow you very easily to add another software that works on this hardware, to add a third software operating system that runs on this hardware, because you have something in the middle. You can't do such before. You can't have another one unless on the action that we have talked about, which is having more than a partition. But you will, from now on, load into the hypervisor, and you will see your multiple operating systems that are working, and you will use all of them at the same time because of the hypervisor. Okay, so you will load your hypervisor on the physical hardware. After that, I'm sorry, we will install the operating system on the hypervisor. Let's take this off. This is affecting the view. Okay, now the hypervisor is called the host. This is two new terms that you must know, and your operating system is called the virtual machine or the guest. Okay, so these multiple operating system, one of them is Mac, the other is Windows, Microsoft Windows, the third one is Linux. All of them are operated and installed on a single computer hardware, and all of them are run at the same time, operating at the same time, and you can control and see the three of them at the same time. You don't need to reboot rapidly and jump from one to another. Okay, so another function for the hypervisor, which is how it's really working, and it's really big benefit that it does schedules the VMs, the virtual machines requests to the hardware. So whenever Linux need maybe 4 cores of the total 12 core of the CPU, at the same time maybe your Microsoft Windows need maybe another 4 cores, maybe they are sufficient or not. This is the problem of the hypervisor, not your problem. Okay, so the hypervisor will first send the request of the Linux or the Mac to the processor, to the hardware, take its part of the resources or what it needs from the hardware resources, apply to you the action that you needed. After that, it will go to apply again the same procedure, but to serve the Microsoft Windows requirements and resources. Or if it was sufficient, it will distribute the hardware resources between these VMs. Okay, so the hypervisor is what take maybe your 12 core processor and virtually makes your processor like 3 virtual processors. Each one has 4 cores and will give each 4 cores to a single virtual machine. It will take your hard drive that you have provided of 1 terabyte, which is 1000 gigabyte, and give like 330 gigabyte for each virtual machine. It mustn't be equalized. You have full resiliency to choose whatever you like. Maybe you will give for Linux half of your specification, and the other operating system will give each one of them the rest. You can do whatever percentage or distribution you would like. You are not committed for some certain specifications or distribution. Okay, so far this is the concept of virtualization, how it's happened. It has 2 main concepts that it was created for: virtual software applied on whatever hardware I provide, and next having multiple virtual devices or appliances built on a single hardware appliance. Okay, so these are the 2 main reasons and functions of virtualization. It's all happened by the hypervisor. These are the benefits of the hypervisor and the big uses of it when it came out to the world to us. So this is only the concept about it. We will talk in more details in the upcoming video. Thanks for watching and goodbye.